In this video, we're going to have an introduction to determinants, so we're familiar with that term already because we have talked about it in previous sections. This is going to go a little bit more in depth as to how to compute a determinant. The follow-up to this video, 3.1.2, will go through cofactor expansion. So what do we know about determinants? Well, we already know the basics, which is that if the determinant of a matrix A does not equal 0, then A is an invertible matrix. We also know that if we have a 2 by 2 matrix, that we can find the determinant by taking the product of A and D and subtracting the product of B and C. Let's change the notation just a little bit, and the reason I'm doing this is, of course, because we're going to change the notation for different or larger matrices in just a moment. So looking at a little bit of a change in notation, notice all I'm doing here is I'm using our row and column for the address of each entry. So A11 is, of course, first row, first column. A12 is first row, second column. And we continue A21, A22, etc. So to find the determinant then, my strategy isn't going to change. I'm going to take the product of A11 and A22, and I'm going to subtract the product of A21 and A12. For instance, let's go ahead and find the determinant of A for A as 4, 3, 2, 7. So I would take determinant of A to be 4 times 7 minus 3 times 2, which is 28 minus 6, which is 22. So fairly easy for a 2 by 2 matrix. My problem now comes from the fact that I don't know how to compute determinant of A if A is, say, 3 by 3 or 4 by 4, etc. through n by n, where n is any integer. I should have included that. N is some integer. No, n is a natural number because I can't have negatives. N is a natural number greater than or equal to 3. So I don't know how to do that yet, but good news, that's what we're going to learn. Here's our definition. And just know that this definition will make a lot more sense when we actually do an example, but we should talk about the actual mathematical definition first. The determinant of an n by n matrix where n is greater than or equal to 2, and A, which is our matrix, is composed of all of the entries in the form Aij, where I is the row and J is the column, is the sum of n terms of the form plus or minus A1j determinant A1j. So that might seem a little confusing because we don't know what determinant A1j means, and plus minus, when is it plus, when is it minus? Well, plus and minus will alternate, and A11, A12, all the way through A1n are the first row entries of A. So essentially what we're saying is to find the determinant of A, which of course is what we're trying to find, we're going to take A11 times the determinant of A11, and then A12, and notice this one's a minus, A12 times the determinant of A12, and this one's a plus, and A13 times the determinant of A13, and that pattern continues. And if you were really looking at the full pattern, you could write it instead as the summation. And again, we haven't talked about what this means yet, and I promise you we will in just a moment. But the summation of all of those terms could be written in this form. Notice I have negative 1 to the 1 plus j, and that is just going to tell me whether it's a plus in front or a minus in front. And then this is the same notation. So A1j, determinant A1j. So here's what we mean by that. To find A1j, or the determinant of A1j, it's essentially a submatrix. So it's a smaller matrix of A formed by deleting the ith row and the jth column. So let me show you. If I were looking at A11, determinant A1J, here's how I would find that. A11 is this guy right here. And then I would be finding the determinant of A1J. And A1J is found, and watch this, I'm going to take away the row and the column that A11 is in. So whatever this term is, I take away the row and the column, and I write the matrix that is left over. So A22, A23, A32, A33, and good news, I know how to find, let me make that white because I'm OCD like that. I can find the determinant of a 2x2 matrix very easily because we just reviewed how to do that. So let's look at one more just to make sure we get it. Say I had A13. A13 determinant, A13 would be whatever term is in A13, and then the determinant of, and again, if I'm looking at A13, I take the row and the column, and what's left over is A21, A22, A31, A32. So let's take a look at how this might actually work with an example using this definition. So I want to find the determinant of A, for A is this matrix. So I'm going to use that definition that essentially says I'm taking plus minus A1J determinant A1J, where pluses and minuses are alternating. So I didn't write the full summation here, but you get the idea. What I would do to find the determinant of A would then be to take A11 and then determinant of A11 minus A12 determinant, I don't know why I can't write today, determinant A12, and then plus A13 determinant A13. And I stop there because obviously there are 3 rows, and so, I'm sorry, 3 columns, 3 rows and 3 columns, but 3 columns telling me that that is the very last one. So now let's actually start looking at some numbers. The determinant of A, A11 is 1, and then I'm going to find the determinant of, and again I'm going to take out the row and column that 1 is in, so that gives me 4, -1, -2, 0. So it's 1 times the determinant, and then minus, and then A12 is first row, second column, so that's 5. And then I'm going to find the determinant of, and again I'm just going to take out that row and that column, so that leaves me 2, -1, 0, 0. And then I'm going to add A13, which is 0, and then determinant of 2, 4, 0, -2. Now you might have just said, well, it's 0, so who cares? And I agree. But for the sake of doing our first example very well and in a lot of detail, we're going to do it just like this. Now I do want to point out to you notation that you will likely use instead of writing determinant each time. If instead of using those square brackets that we use to show that it's a matrix, I can write 1 times, and then I'm going to use these straight brackets, and the straight brackets tell me that I'm finding the determinant. So that's what you're going to see more often, is those straight brackets that tell us we're finding the determinant, as opposed to writing out determinant and then writing the new matrix. Whoops. So let's go ahead and compute this. This is 1 times 4 times 0 minus -2 times -1. This is 5 times 2 times 0, which is 0, minus 0. And this is 0 times negative 4 minus 0. So my determinant of A in this case is 1 times negative 2, negative 5 times 0, and 0 times negative 4, which gives me negative 2 minus 0 plus 0, which is negative 2. So that means my determinant of A is negative 2, which is just fine. Here's one for you to try on your own. So again, use those same steps to find the determinant of A for this matrix A. When you feel satisfied with your solution, press play to see how you did. All right, so again, to find the determinant of A, I'm going to start by taking A11 and then determinant of A11 minus A12 determinant of A12 plus A13 determinant A13. So that tells me 1, which is A11 entry. Get rid of those. What's left? 1, 1, 4, 2. Again, I'm just using that matrix, the different signs on the outside, the vertical lines in place of the brackets. So that tells me that I'm finding the determinant. Minus, and then A12 is 3. I take away that row and column. 2, 1, 3, 2. And then plus, and then I have 5. Take away that row and column, and that leaves me with 2, 1, 3, 4. So that means the determinant of A is 1 times 2 minus 4 minus 3 times 4 minus 3 plus 5 times 8 minus 3. So the determinant of A is 1 times negative 2 minus 3 times 1 plus 5 times 5, which is negative 2 minus 3 plus 25. So my determinant of A is 20. Hopefully you did that just fine. Stay tuned. On our next our next video, we are going to go through what's called cofactor expansion.